Hello, my dear friends, welcome back. I believe that you've all gone through the first video of differential equations where we have discussed about the degree and order, which is very important for multiple choice questions. Now let's move on to the second topic of this particular chapter. Remember, I told you there are 6 subtopics. So this is the second one, that is general and particular solutions of a differential equation. This is also not a very difficult question, basically like for 2 marks sometimes. Now, but before we really discuss about this, like, let's see what do we mean by solution. If you remember, like for example, linear equations we have done, trigonometric equations we have done. So like for example, if we have a linear equation like 4x plus 2 is equal to 6. So if you have a question like this, then if I tell you to find the solution for this particular equation, then normally what happens is x is equal to 1 is a solution, because 4 into 1 plus 2, that's going to give us 6. So if you use the value of x as 1, then what happens? The equation is satisfied, and that's when we say that x equal to 1 is a solution of the particular linear equation. Similarly, for quadratic equations also, like for example, if x square is equal to 1, then what will be the solutions of x here? It would be x equal to 1, x equal to minus 1, because 1 square will be 1, minus 1 square will be 1. So for a quadratic equation, of course, we have here 2 solutions. For linear equations, we have 1 solution. For cubic equations, we will have 3 solutions. So let's keep that in mind also. Likewise, in trigonometry also, in class 11, we have studied about trigonometric equations. So there also we have learned how to find out the solution of a trigonometric equation. So now here we will be discussing about differential equation. So if you remember, differential equations were like polynomials only. So it's almost going to be the same, it's just that instead of the variables, we have the differentials that are involved. You remember, right? Okay, so that means what are we going to do? We are going to try to find out the solution of a differential equation. So what do we mean? What shall we mean by solution of a differential equation? It can be written as like a function. Better to write down all these notes. A function of the form y is equal to f of x plus c, where c is a constant, which satisfies a given differential equation is called its solution. Okay, so like for example, it can be like d square y by dx square plus y is equal to 0. So what we have here is we have a differential equation here. So when I tell you to find out the solution of this differential equation, then it simply means, let's keep it very simple. It simply means like that particular that value of the function y, which when you substitute here, this equation will be solved, that is, it will be equal to 0. Okay, so it's basically like what is that particular value of y, which when you put here, this equation will be 0, or in other words, like this differential equation, like what was that particular equation function from which this differential equation was derived, something like that also. So if we see here, like for example, if I take just an example, if I take a function that is y equal to a cos x minus b sin x, then what will happen here is, if I differentiate it once, then I'll have a minus sin x minus b cos x. So then again, if I differentiate it 2 times, then I'll have minus a cos x plus b minus sin x. So that will be minus a cos x plus b sin x, which can be again written as taking minus common, a cos x minus b sine x, d square y by dx square. So that's d square y by dx square is equal to minus this from, we can simplify it in our own ways, equal to minus y. So then d square y by dx square plus y equal to 0. We can do it like this also, or you can just substitute the value of this equation here also. Then again it's going to be same, the equation will be satisfied. So what happens here is this function, that is y equal to a cos x plus b sin x, is the solution of this differential equation. I hope you get that, na? So in other words, as I said, it's something like, okay, here we have a differential equation. So something like a question like, this differential equation came from which function? Something like this. It is derived from which function? So in that case, my answer is, okay, this is the function, this is one of those functions from which this differential equation is satisfied. Solution. So what is that particular value of, so to be precise, what is the particular value of that particular value of y, that function, which when you substitute here, this equation will be solved, this differential equation will be solved, and that value is, that the value of that function is y equal to a cos x minus b sin x. So this is the solution of this particular differential equation, I mean. Getting the point, no? All right, solution. So just like here, what is that value of x, which when you substitute in the equation will be satisfied. So same same as here. So this was a linear equation, we have a differential equation here. All right, but solutions also, there are actually two types. We have the general solutions and we have the particular solutions. We have the general solutions and the particular solution, just as the topic suggests. This solution that I got for this differential equation, this goes to general solutions. Particular solutions will be like y equal to, instead of this arbitrary constants, if I have an equation like y equal to, if I have an equation like y equal to 4 cos x minus 3 sin x. So in that case also, if we differentiate like y dash, that's going to be minus, I'll do it directly, minus 4 sin x minus 3 cos x, differentiated 2 times, that's going to be minus 4 cos x minus plus 3 sin x, that's going to be y double dash by minus common 4 cos x minus 3 sin x. So y double dash equal to minus of y, so d square y by dx square y plus y is equal to 0. So this also satisfies this particular equation, but here what happens, this is a particular solution. Now let me tell you the difference between particular and general solutions. You see, what happens here is the constants that we had in the first and the second case, here the constants were, constants, 4, 3. Here what do we have? We have arbitrary constants. What do we have? Once again, we have here arbitrary constants. Okay, arbitrary constants. Arbitrary constants. Okay, so this is looking a little bit messed up. Let's move to the next page. So what do we have? That is, we have the first solution was a cos x minus b sin x. Second solution was 4 cos x minus 3 sin x. So here if you look at the constants, in the first case we have here what? Arbitrary constants, arbitrary arbitrary constants. So that, and this one we have here particular or specific constants. That is the only difference between general solution and particular solutions. General solutions and particular solutions. So in general solutions, the constants that we will have will be arbitrary constants, and in particular solutions we will be having specific particular constants. So like basically, see, arbitrary constants are also constants only. Okay, so it's not different. It doesn't mean that it will be variables like x, y and all. No, these are also constants, but arbitrary constants. Just like the way we are done, integration. definite, indefinite. No, so in indefinite integration, what do we have? Integration of x with respect to x is x squared by 2 plus c. So this is like a general formula that is given to us. But when we go for the same integration with like a definite integral, what do we have? We have here x squared by 2. So this constant, general constant, disappears, 1 to 2. So that's like 2 squared by 2 minus 1 squared by I hope I'm correct, yeah, 1. So 2, 4 by 2 minus 1, so we have a 2 minus 1, 1. So what do we get here? We get a specific solution here, no particular solution that we get. Here what do we get? We get a general solution, general value. That is the only difference. Even like, for example, when I talk of a general equation, then general equation like this is the equation of a circle, x squared plus y squared equal to r. So here r is the arbitrary constant here. But when I go for the equation of a circle like x squared plus y squared equal to 2 square, so then it means I'm talking of just one circle whose radius is 2. Whose radius is 2 units. Then here this r value takes a specific value, so it's a particular constant. No, a constant 2. This r value here represents an arbitrary constant. That means here when I'm talking about this r can take any value. So this circle, equation of a circle, I mean this one represents a circle whose radius can be like anything depending on the value of r. So it can be a circle with radius 1, it can take radius 2, it can take radius 3 units, it can take radius 4.5 units, and so on. So that is the only difference between arbitrary constants and specific or particular or constants. All right, so when in the value of the function of the solution we have arbitrary constants, that solution is known as a general solution. And when we have constants in our given solution, in our given function, then those solutions will be called as particular solutions. All right, so I guess that would be fine. All right. Okay, so with that, let's move on to a question. Now, of course, in the next exercise, we'll be talking about this also, but like always do remember, okay, like one important point that I'll give you is like the number of arbitrary constants, okay, the number of arbitrary constants in a general solution, okay, will be equal to the nth order derivative. That means like, for example, in the differential equation, like for example d square y by dx squared is, let's say, plus y equal to 0. So here what do we have? Like we have order 2. So that means in the general solution of this differential equation, okay, we should also have 2 arbitrary constants. So it depends on the order, okay, number of order, I mean not number, sorry, the order. According to the order, there will be respectively there will be the number of arbitrary constants. So if the order is 4, we should be having 4 arbitrary constants in our solution, in the function, okay. And when it comes to particular solutions, then in a particular solution there won't be any arbitrary constants. In a particular solution there won't be any arbitrary constant. Remember this is a general solution, right? This is a particular solution. So in a particular solution, depending on the order of the differential equation, there will be the number of arbitrary constants. But when you talk of a particular solution, there are no arbitrary constants. What do we have? We have constants only. So sometimes you might just get a question like, in a particular solution of like order 2, how many arbitrary constants will be there? Our answer will be 0. But if the same question is like, in a differential equation of order 2, how many arbitrary constants should be there? Then the answer will be not 0, answer will be 2. All right, so let's just summarize this once again. That is, here in this exercise we will be talking about general and particular solutions of a differential equation, which means that, for example, if I have a differential equation like d square y by dx square plus 2y equal to 0, then what I'm asking is what will be the value of this function y, which will be of course with respect to x, represented in terms of x. So what should be the value of the function y such that when it is replaced, when this value is replaced by the function, this equation will be satisfied. All right, that is what we mean by solution of a differential equation. And as mentioned, we have two types of solution, that is a general and particular solution. When the solution of a differential equation contains arbitrary constants, that solution is known as general solution. And when the solution of a differential equation we have constants instead of arbitrary constants, we have constants like 4, 3, 2 and all, then that solution will be known as particular solutions. Okay, just for our knowledge. All right, and lastly, as I said, depending on the order for a general solution, there will be equal number of arbitrary constants. If the order of a general solution is, if the order of the differential equation is 2, then in a general solution there should be 2 arbitrary constants, but in a particular solution there won't be any arbitrary constants, because in a particular solution we have constants only. See, yeah, exactly what we have here is in C, question number 11. You see, the number of arbitrary constants in the general solution of a differential equation of 4th order are, so since it's a general solution of 4th order, there should be how many? 4 arbitrary constants. But when you come to this question, that is a number of, again, arbitrary constants in a particular solution. Remember, in a particular solution we don't have arbitrary constants, we have only constants. Of a differential equation of 3rd order are 3rd order or 10th order, doesn't matter, answer will be 0, because in a particular solution we have only constants, we don't have arbitrary constants. Got the idea now of arbitrary constants? Okay, all right then. So next up, in the next video, this was a short introduction on solution of a differential equation. Okay, so in the next video we will start with the exercise, since I do not want to make the video very long for you, otherwise you'll become bored, right? So in the next video I'll come up with the solution of exercise 9.2. So till then, go through this video. I'll see you in the next video. Bye bye.